Hi, welcome to Chapter 14. Chapter 14 is probably I won't say the most important, but it's at least the one that has the most stuff in it when we get into this thing called object-oriented programming. So what we're going to basically be doing is talking about classes and then basically creating objects from these classes. So the topics are going to be basically what is object-oriented programming, what are classes, using what's called this UML, the Unified Modeling Language, to design these classes, find the classes and the responsibilities on a problem, inheritance and polymorphism. So we'll basically cover a lot of different topics in this particular chapter. So it might seem a little confusing, might seem a little out of the ordinary, but just realize this is the future, or this is the future of programming. This is what programming today is all about, is this thing called object-oriented programming, or OO programming. Okay, so let's just dive into it. So procedure programming is a method of writing software. It's a programming practice centered on the procedures or actions that take place in a program. Object-oriented programming is centered on the object. Objects are created from abstract data types and encapsulate data and functions together. So we've kind of talked about some of these different items, like the length of and random. So those are basically objects, and what we're doing is it's pre-written code that's out there, and we just basically here are using one small piece of it. For example, random. I'm telling random, hey, I'm giving you a parameter. I want you to return a random number between these basically numeric values. And so that is basically an object that I'm calling. Now it's encapsulated. What does that mean? That means that all of this code is encapsulated inside of this object, and this object is there that holds this data, this information, and we just call that object and basically call it by this parameter, and it gives me back stuff. I don't know how it works. I don't know why it works. I just know that it does work, and when I basically ask for this, it gives me something back in return. Okay, and I want to go by that. So probably the most important thing about objects is they hold data. They also are reusable. That's the best part about an object, is they are reusable. Okay, that means once I've got an object created, I can actually modify the data they hold, and then I can have it basically give me back different things. So the very first thing I want to talk about is what is inside of an object. There's two basic things inside of an object. Variables that we call instance variables, and methods, otherwise known as procedures, that we have talked about in the past. So I like to basically, the generic terms I like to use are nouns and verbs. Nouns are the things that describe an object. The verbs are things that it can actually do. So for example, I have this bottle of hand sanitizer. Okay, if I were to describe this, so some of the instance variables, the nouns, are the labeling, the plastic, the shape of it, the ounces that it holds. Just so think of some of the different nouns that it can do. Then let's talk about what it can do. Well, it holds the data, or holds the liquid. We can hit this pumper and it pumps stuff out. I can turn this pumper around so it basically fits the direction that I want. It's also got these threads on here, so if I want to lock it down, I can push it down and screw that in there, and so that's locked if I want to take it for travel. I can unscrew this lid and I can refill it. That's another verb that it can do. So that's basically, this is an object. We'll talk about the nouns, we talk about the verbs. Those are basically the instance variables and the methods. Okay, so that's the two basic things about an object, are those two things. Okay, so an everyday example of an object is the current second. Has a value of a range of 0 to 59. The current minute, the current hour, the current time the alarm is set for, whether the alarm is on or off. Okay, so these first three things are instance variables, the seconds, minutes, and hours. And then the next two are basically methods. These are the verbs of the object. The time is basically we want to set a time for the time the alarm to go off. And then basically whether the alarm is on or off. That's also another the switch on our alarm to turn it off and on. I don't want to talk about those. Okay, so let's talk about classes. So we're going to be developing these things called classes. And these classes, like I said, hold two things: instance variables and methods. So what I want you to think about a class is this. A class is the blueprint for an object. Meaning, once I have my class created, I can create multiple objects from that class. So I can create a blueprint for a house, correct? And I could create many houses from that same blueprint. Now, are all the houses going to be identical? Probably not. They're going to have different colors. They're going to have different number of windows. They're going to have different number of outlets, different types of doors, different types of carpeting. So they are basically somewhat different. Well, our classes are a little more generic, and the fact that I can say number of rooms to a house. So that would be an instance variable is number of rooms. And I can set that instance variable to, let's say, 3 for one house object, and it's got 3 rooms in that house. The next object I create from that same class, I might set it to a 4. So the house I create with that is a 4-room house. They're both created from the same class, but they're just totally different objects. For example, I can create an employee class. And that's probably an example I'm going to do here in just a second. So this employee class, I'm going to have a bunch of different instance variables. Name, address, city, state, zip, hours worked, pay rate. Now I can create an object, an employee object for each employee that I have. And I basically use that one class. I create that one class, and I create an object for each employee from that one class. I call the first object employee 1, employee 2, employee 3, employee 4, employee 5. Now each one of those employees are basically have the same fields, the same nouns and verbs, the instance variables, the same instance variables, the same methods, but what's inside of those instance variables are going to be different for each employee. Names are going to be different, addresses are going to be different, pay rate's going to be different, hours worked are going to be different. Okay. What's nice about this is it's called the cookie cutter approach. I create one class and I can stamp out objects from that class and create as many objects as I need from those classes. I'll talk about this more, this inset class, and well, okay, let me talk about it. So I create an inset class, and I can create a housefly object from that class, or I can create a mosquito object from that class. So let me do this. Let me bring up Raptor, and let me show you what we need to do to basically utilize object-oriented programming inside of Raptor. So the very first thing we need to do is we've been working in intermediate mode. Okay, so if you click on this mode up here, it says intermediate. When I click it to object-oriented, we basically now have 2 tabs at the top. We have UML and main. Okay, so let's first talk about where does the chapter talk about UML? Here we go. So 14.3 talks about a UML. So the first thing we need, so we're going to have a box that has 3 sections to it. The first section is now the name of our class. The second section is going to be where our instance variables are contained. And our third section is going to be where our methods are basically contained. Okay? So we got name of our class, instance variables, and remember the instance variables hold the data, and then the methods actually manipulate the data, do something with the data. Okay, so that's basically what we're working with right there is a UML. Okay, so that's the first thing that our we need to talk about within Raptors. We needed to develop a UML. So I'm going to create an employee class. So the very first thing I'm going to do is up here, I've got all these different items. If I point to this first one, it says add a new class. So when I click on it, it adds a UML to my screen. So it automatically comes up with the name of new class. When I click on it, it's got name, new class. Well, I'm going to give it a new name. Now, we always give classes, we always start with an uppercase letter. So I'm going to use uppercase employee, okay? Access is public. I want it to be basically seen by everybody. If it's private, only this method or this particular application can see it. I don't want that. I want everybody able to see this application. Okay, so now I have an empty employee class right now. Now what I need to do is I need to add my instance variables. So I double click on this guy and it brings up this screen. Now down here I've got this blue, which is add a new field, which is an instance variable. And this pink box, it shows it in motion, kind of giving you that inference that it's moving, so it's basically a verb. And if you point to that, it says new method. Again, a method's like a procedure. Okay, so I click on this blue name. And the very first thing I'm going to do is we always start our instance variables lowercase. Okay, so I type just like our variables. So I type in name, and what data type is it? It's a string, and it's going to be private. Now, I'll talk about that more in just a second. Private meaning only this class can see it, nobody else. Why do we want a variable that only we can see? I'll talk about that more in detail in a little bit. Okay, so make sure you tab all the way through so everything sticks, and then I click on another blue box, and I'm going to type in address. It's also a string. I'm going to add another one, which is city. It's a string. And state, it's a string. And I'm not going to worry about zip code right now. We're going to talk about hours. I'm going to leave that as an int. That's a default. I'm going to add another one, which is a pay rate. Now, just like I talked about before, talked about camel casting, we always use camel casting. So if it's two words put together, the second words or any other word attached to that is going to be uppercase. So pay rate, that's going to be real, okay? And so now I have my instance variables. Now notice over here I've got name, which is a string, address, which is a string, city, which is a string, state string, hours is an int, and pay rate is a real. They have a minus sign next to each of them. A minus sign says this is a private variable, instance variable. Only this class can see it. Well, how am I supposed to manipulate these variables? Well, we use things called methods to now manipulate these guys. So now I'm going to click on a purple, which is a new method, and I'm going to say this is a set name. It's a name of the method, and I need to pass something into this. So this type is what? No, I'm not passing anything into it. Yes, I am passing something into it. So I am going to receive this as a string. Now, once I do that, and I'm going to leave it public. Now, once I do that, up here I've got public string set name, and I've got parentheses. Now, what I need to do is in order to set the name, I need to receive something from the user. So I'm going to receive a string, and it's called name. It's the same exact name as what wow. So I'm going to get in a variable called name. I'm going to set a variable called name. We can do that legally. Okay, so now I've got set name. It's a string data type. It's set to public, and we are good to go. I'm going to add another one, which is set address it's receiving, it's going to receive a string. Oh, no. You know what? I should be a void. Sorry, my bad. This should be a void. I'm not passing anything back. The only time I need to set that is if I'm passing something back. I'm just receiving, so I need to address that here just a sec. This is a string, again, called address, which is totally legal. I need to set name. I need to change that to a void. There we go. All right. This type, if I'm passing something back. Now, set means I am setting this particular item. Okay, so let me add another one. It'll make more sense in a second. If you're a little confused, don't worry. It's going to make more sense here in just a minute. Okay, so I'm going to add a new one, which is set city. It's a void. Again, I need to pass something into this method, so I'm going to put, it's a string, and it's going to receive city. I'm then going to add set state. Again, I'm going to change that to a string, and state is the variable it's going to receive. And then set hours. Now, that's going to receive it as an int, and it's going to receive hours. And then finally, it's going to set pay rate. Which is a real pay rate. Okay, so notice these guys have plus signs in front of them. That means that this is a public. Okay, so now this is why we make our instance variables private. We now control how our users update these instance variables. They have to use this method to do it. They just can't have direct access to that variable. They have to use a set to do it. Okay? So, if I come over here to employee now, notice I've got all these tabs up here. I've got set name, and it's receiving name. So here's what I can do. So I'm going to click on an assignment. I'm going to click right here. And I double click on it. Now, since I have two variables with the same exact name, I got name, I've got name. It's receiving name in, and the name of the field I'm modifying is name. Every class or every object has its own nickname. That nickname is this. So if I type the word this dot name, it's talking about the instance variable name. And I'm going to set it to name. What is that one? That's this variable up here that is basically being brought in. So I'm taking this variable and I'm setting whatever the contents of that is to this dot name. I click done. That's all we do. That's all we do in a set method. I come over here to set address. I do the same exact thing. I type this dot address is equal to address. Again, this address represents the address being passed into this procedure, this method, and this address, this dot address, represents the instance variable. So whatever is being brought in is being put into the instance variable. Okay, I'm going to pause the recording. I'm going to do the rest of these so you can kind of see what's going on, just to speed up the time a little bit. Okay, so I have all of these set methods all set up. Okay, so if I go ahead and now on my main, I'm going to do this. Now, in order to use a class, I'm going to create an object from that class. So to do that, I'm going to put an assignment statement in here, and I'm going to say, double click, I'm going to say employee 1 is going to be set to. Now, in order to use a class, I have to create a new instance of that class. Now, a new instance says this. It says, create a new object and take all of the guts from that class and put it into that object. So in order to do that, I have to use the word new, which says create a new instance, and set that to capital employee. Okay? So employee 1 is basically equal to an instance of a new employee. So I've just created an object called employee. Wow. We're done. So basically, new employee is basically set. So now, I need to call a set, that set method. To do that, I used to use a call. So I come in here and I double click and I say, employee 1 dot, since it's a method inside employee 1, because employee 1 is a new object with all of those methods, I type set name, and then I put a parenthesis, Mark Webb. Okay? So basically what that is doing, it's calling the method set name, and I'm passing in this parameter Mark Webb, and it's basically going to take so Mark Webb is the name right here, and it's basically be put into the instance variable name. So now name holds Mark Webb, the data. I do another call, and I say employee 1 dot set address. I put 123 Main Street. Another call, employee 1 dot set city. I'll pass in Morton. And I'm going to pause the video again just to save some time here. Okay, so I've called all of my set methods. So there I have employee 1 set address, set city, set state, set hours. Now notice hours doesn't have the double quotes on it because that's only for strings. And then I've got set pay rate 18.75. So when I run this, I come over here, and now in my window I can see that I've got this employee. I basically expand it, and it says the name instance variable has been set to Mark Webb. The address is set to 123 Main Street. The city is set to Morton. The state is set to IL. Hours set to 42, and pay rate is set to 18.7500. Okay, so pretty cool. So basically it works pretty good. So notice that I've got this employee 1, and there is what's called its unique identifier, and it's 7995840. Well, the employee object with that same unique ID contains this information. Okay, so I've got this object. It's holding that data. What do I do with it? Well, I got some more things to do over here in my UML. So I'm going to double click. So I've got some set statements, so I can take each one of those instance variables. Again, through my code, I can control how this user manipulates each one of those instance variables. I now have to give the user the ability to get the data from there. So I'm going to then click on this little purple thing again. I'm going to say get name. Now this is going to return something. I have to tell it the data type it's going to return. It's going to return a string. I'm passing nothing into this because I'm just telling it give me what's in the name. So I click that. I add another method called get address. Again, it's returning a string data type. I'm going to add get city. It's returning a string data type as well. get state. That's a string data type. And then I have get hours. Now this is returning an int data type. So I click on the drop down, there's int. And then I've got get pay rate. And it's returning a real. Okay. So I look over here, I've got some sets, now I've got some gets. Now in the programming world, once you get into actual object-oriented programming, these are nicknamed in the programming world getters and setters. Okay, you'll hear that term a lot once you get into that language. It's called getters and setters. I think this book actually talks about getters and setters. So now I've given the user the ability to set each one of those instance variables via a method. Now I've given them the ability to get that data. Okay, again, I don't want them to have direct access to that field. That's why I made it private. But I'm giving them access to each one of those fields via these getters and setters. So now if I go back over here to my main, I can actually stick my output over here, and I can say employee 1 dot get name. I can put my parentheses in here, it doesn't matter. And then I can come over here on my next line, I can say employee 1 dot get address. Then on my next line, I'm going to say employee 1 dot get state, and then I'm going to put a dot or a plus sign, double quote, comma, space, double quote, and then I'm going to put another plus sign and say employee 1 dot get. I'm sorry, that needed to be, this is get state, my bad. The other one should be get city. Okay, so city, comma, space, get state. And then this last one is going to say double quote, gross pay, colon, space, dollar sign, plus sign, and then I'm going to put in parentheses employee 1 dot get hours, and then multiply that times employee 1 dot get pay rate. I forgot to put a double quote after the dollar sign. There we go. Okay. So here I set each one of those instance variables via a setter. Then I display each one of those instance variables with a getter. So if I run this now, what did it say? I forgot to go in here and set these guys. I created my... So here's what I need to do is I need to say get name. I need to... Now, here's where it's different. This is the one thing that gets different in Raptor, is we now have a new item called return. If I click on that and I click inside of here, I can now say return this dot name. Okay? That means, remember, this is the nickname for this object. Return the name instance variable of this object. I click done. I go to get address, I'm going to return this dot address. This dot city. This dot state. This dot hours. And finally, whoop, this dot pay rate. Okay, now let's see if this works. Let me save it first. Let me run it. And get hours is not found. Why is get hours not found? Do I need my parentheses? Maybe that's what it is. Yep, that's what was missing. Okay, so notice, let me do this real quick. I always like to do this. Add a call statement at the top, the very first thing, and say clear console. Now, another thing I want to do is right before I display this gross pay is I'm also going to call set precision to 2 decimal places. And now let's rerun it. And sure enough, now it's got Mark Webb, 123 Main Street, Morton, comma, space, Illinois, gross pay, $787.5. Okay. Now, I could do this. I could come down here and basically do another assignment and say set employee 2 as a new employee. And now I have a new object called employee 2, and I could go through the same setters and getters of employee 2. Employee 1 holds its data, it's an object by itself, and employee 2 is another object down here by itself, so it now represents employee number 2. So each one of these objects was created from a class, because remember, I can't use a class directly. A class is designed to be a blueprint. So the blueprint basically describes all of the instance variables, all of the methods, and then I create objects from that class via those items. Okay, so that's basically pretty much the basics of object-oriented programming. Okay, we create classes, we create objects from the class. A class itself is a blueprint to create classes from. Okay, so let's go back to so let's go to program number 1, and so let's see what they've got. So let's open up program 1. And so here's what we've done is I've got this cell phone class. I've got 3 instance variables. I got manufacturer, which is a string, model number, which is a string, and retail price, which is real. I've got 3 sets and I've got 3 gets. I've got getters and setters. I got set manufacturer, which basically brings in the manufacturer, the model number, which brings the model number, and the retail, which brings in that, which is real, and then get returns a string, model number returns a string, and get retail price returns a real. If I come over here to my cell phone, I've got all of these methods up here. My setters all basically say this dot manufacturer is equal to whatever being passed in, model number, set price, and then getters do a return. Okay. So here's my main. I created a new object called my phone. It creates it from a new instance of the cell phone. Then I say my phone.set manufacturer is Motorola, double quotes around it. And my model number is an M1000 and my retail price is $199.99. Go ahead and set my decimal places to 2. And then I say the manufacturer of my phone.get manufacturer. The model number is that model number. And then I put retail price is retail price. Okay. That's as simple as it gets. So when I run it, it basically is the manufacturer is Motorola, the model number is M1000, the retail price is $199.99. Okay, so again, the employee class that we just created is a lot more complex than this, so you should have a good understanding. Okay, so we've got our class created. I can now create multiple objects from that same class. I could create another My Phone 2, My Phone 3, My Phone 4. Does it have to be My Phone? No, it could be anything you want. I could call it Cell Phone. I could call it Work Phone. I could give this object name anything I wanted. Again, just when I talked about naming variables, give it a good, useful name. If you give it a good, useful name, it will basically have a lot more meaning and easier to understand for anyone who basically has to maintain this code. Okay. So in pseudocode, we first declare a cell phone object called My Phone. Okay, just like we did with a string. I'd say declare string name. Well, this is a cell phone object. So what data type is this My Phone? It's a cell phone data type. I set My Phone equals a new instance of cell phone, left and right parenthesis. I then call my phone.set manufacturer, set model, set, okay. So pretty much the same thing as we did in our flow chart. Now, the true name of our getters and setters are called accessor and mutator methods. That's kind of the formal name. Accessors are getters, mutators are setters. But down here it says note, mutator methods are sometimes called setters and accessor methods are sometimes called getters. You'll hear that term a lot in Cite. In fact, one of the editors I use, which is Eclipse for Java, I can actually go up to the menu and say automatically create getters and setters. It actually says getters and setters in there. Okay, so now we talked about program. Wow, let's see if it shows. We're going straight to number 4 here. Where was number 3 and 4? 2 and 3. Let's take a look at 2. So 2, I create a new instance of My Phone. Okay, so now let's talk about that in just a sec. That should be 14.4, right? Okay. Okay, so this next section talks about constructors. Now, a constructor is a method. Now, the thing about a constructor is it's going to be executed at instantiation time. So it is a method that gets executed only once, and it never can be executed again. It only gets executed once, and it only gets executed at instantiation time. And so a constructor is a method that is automatically called when an object is created. So once we instantiate or create an object, it's automatically created. Now, we've seen this when we use the length of. I would type the length of, and inside the parentheses I would type something in there. So what it's doing is creating an object and returning something. So here's how we use a constructor. So I'm going to first come over here to my UML, and here I've got set manufacturer, set model, set retail. Well, let me do this first. Let me go over to my employee first. Let me do my employee class that we've been playing around with. Let me open that guy up. And now I'm going to come over to my UML, And I'm going to double click right here, and I've got my blue box, my pink box, and I got this white box which is called a new constructor. I'm going to click on it. When it does that, it's automatically called employee. It automatically has the same name as my class. That's automatic. Uppercase E and everything. It never returns anything because it can't return anything, and it's public. Okay? So, we can do this though. We can pass things into it. I'm going to type string name, comma, string address, comma, string city, comma, string state. I'll leave it just like that. So now when I close this and I come back over here to employee, if I come all the way to the right hand side, I now have this employee method. I click on it and it says I'm bringing a name, address, city, and state. So here's what I do is I click on my assignment. Now think of this as kind of a setter. I'm going to double click. I'm going to say set this dot name to name, this dot address to address, this city, this dot city is equal to city, and finally this dot state to state. Now when I save this, I'm probably going to get an error if I try to run this again. So if I click run, I basically got, and notice I've got some red over here, and it basically says went ahead and created this my employee number 2. Okay, but I still was able to create employee number 1. So if I come down here to employee number 2, so here's what I'm going to do. Is this guy, since this gets created instantiation, I'm going to put in parentheses. I'm going to type Mark Webb. No, Joe Smith, comma, 456 Elm Street, comma, Peoria. Notice I'm putting double quotes around all of them, and double quote IL double quote, and then a ending parenthesis. I click done. So here's what it's doing. So now when I run this again, notice I've got 2 employees. I've got my employee 2 and my employee 1. And this guy now has Joe Smith, Elm Street, Peoria, Illinois, and it's got nothing in hours and pay rate. And the reason being is my constructor was able to read those parameters, and again, this method automatically got created or automatically executed at instantiation time. It automatically brought in Joe Smith, that address, Peoria and Illinois, and then it basically went ahead and set these 4 fields. So now, so it's kind of like I create an object and basically put data in it all at the same time. Now I could take this a step further. If I come back over to my UML, I could come down here and on my employee constructor, I could go ahead and up here in my parentheses, I could put comma, int hours, comma, real pay rate. So now I come back over here to my employee and I come in here. Now notice I've got in hours and in pay rate. And I've got those 2 coming in, so I can come down here to my assignment and say this dot hours is set to hours, and this dot pay rate is set to pay rate. Again, this dot pay rate talks about the instance variable. This pay rate talks about the pay rate being brought in to this particular method. But now I got to come back over to my main, and I got to modify this instantiation to comma, say work 43 hours, comma, the pay rate is $17.50. Okay. So now when I run this, and I basically expand my employee 2, which is my 000 at the end, automatically has Joe Smith, Elm Street, Peoria, Illinois, 43 and $17.50. Okay. So constructors are methods that automatically get created at instantiation time. I can create an object and do something all at the same time. So remember how we had a dice method where we actually roll the dice? Well, we could do that. We could create a die object, and at the constructor, I can do this as well. I can actually so let's take employee a step further. Let's take employee a step further. Let's come over here to my UML. I'm gonna double click. I'm going to add a new method that basically is called calc gross pay. It's going to return a real, and it's public. Now when I come back over to employee, I now have this calc gross pay. So it's returning something, so I'm going to click on the return, and I'm going to say this is going to return this dot hours multiplied times this dot pay rate. So now when I come over here to main, instead of right here where I do this calculation, I could actually say, I'm going to get rid of all this. It says gross pay $ employee 1 dot calc gross pay left and right parenthesis. So now I'm letting the so I've got a method that does nothing but gross pay. So now when I run it, notice it still comes up with the same gross pay. Where did that gross pay came from? It came from a method that calculates the gross pay. So this employee class does a lot now. It basically doesn't, it's got getters and setters, but it also has a constructor if I need it. It also has a calculator to calculate gross pay. So I could do this on my main. I could come down here and basically say output employee 2 gross pay $, and then do a plus employee 2 dot calc gross pay. And we could see theirs as well. So now when I run it, okay, what's going on here? I see what I did. I called this employee. No, I don't have double E's down here, so let me add that. Okay. So employee 2 gross pay. This shows their gross pay. So pretty cool stuff. And so that's basically what 14.4 was doing there, was showing how a constructor was used. It was 14.2. Well, I got 14.4 in front of 14.2. Okay. 14.3. So here we create a manufact mod, and then we ask the user to type in each one of those, and then we basically create the object, my phone, with those same parameters, and then we go ahead and do the same exact thing. So instead of actually hard coding that data in there, we can actually the user for that data. So when I run this, it comes up, and we'll say this is a Galaxy. It's an S8, S9, and the retail price is $799.99, and basically, and model not found. What happened there? Set manufacturer. Hold on. Okay, here where I had the instantiation, I was calling it model instead of mod num, because up here I get the phone's model number, get mod num, and I had model instead of mod. Anyways, so let me run it. So the phone manufacturer is Samsung. It's a Galaxy S9, and it's $799.99. And we get done, it goes ahead and manufacturer is this, that. So, works just fine. So you can see we can use, the user then typed in information, and then we took that variable and basically used that to create this instance of this class. So we create an object called my phone using those three variables we got from the user. Okay, so there is what is called a default constructor, and that is the constructor that's always called. Every class has a default constructor, even if there's one not created. It's basically there. So we already kind of covered this, using the UML, so we already kind of know that particular section of code. So let's talk about it in the spotlight. So the owner of Joe's Automotive Shop has asked you to design a program that will service quotes for customers. You decide to use an object-oriented approach to design the program. One of your first tasks is to identify the classes that you'll need to create. In many cases, this means identifying the different types of real-world objects that are present. So basically, here's our algorithm. We got to get a written description of the problem, identify the nouns, and then define. So this particular exercise is going to show us how to, a user comes to us with a problem, how we dissect that problem down into an object. So we're going to identify each one of these items. Physical objects such as vehicles, machines, or products, the roles played by people such as a manager, employee, customer, teacher, student, etc., the results of the business event such as a customer order, or in this case a service quote, record-keeping items such as customer histories or payroll. So here's the description that Joe gives us. He says Joe's Automotive Shop services foreign cars and specializes in servicing cars made by Mercedes, Porsche, and BMW. When a customer brings a car to his shop, the manager gets the customer's name, address, and telephone number. The manager then determines the make, model, and year of the car and gives the customer a service quote. The service quote shows the estimated parts charged, estimated labor charges, sales tax, and total estimated charges. So the very first thing you need to go through is identify all of the nouns in that particular statement. So these bolded words up here are all put down here. So I've got address, BMW, car, cars, customer, estimated labor charges, estimated parts, foreign cars, Joe's Automotive. Okay, so we've got all those. So now we need to go through and figure out what nouns are synonyms, is the same thing as something else. So we know that cars and foreign cars are pretty much the same thing. That's just one object. Joe's Automotive Shop and shop are the same thing as well. So we're going to get rid of foreign cars and Joe's Automotive Shop. Some nouns might represent items we do not need to basically solve the problem. It says we can cross shop off the list because our application only needs to be concerned with the individual service quotes. So we really don't need shop either. We will not need manager because that basically does not have anything to do with what we're trying to basically provide. So we get rid of foreign cars, Joe's Automotive Shop, manager, shop. Okay. Then some of the nouns might represent objects, not classes. Okay. So we're worried about creating a class. So a Mercedes, Porsche, and BMW, we're going to create a Porsche object from a car class. So we don't need Mercedes, we don't need Porsche, we don't need BMW. We also don't need car. We've got car and cars. Well, they both represent the same thing, so we get rid of car. So we basically cross car, BMW, Mercedes, and Porsche off the list. Then we say some nouns might represent simple values that can be stored in a regular variable and do not require a class. So those could be the address, the estimated charge. So again, these could be instance variables. Most likely that's what they're going to be. So address, estimated labor charges, estimated parts, make, model, name, sales tax, telephone number, total estimated charges, and year. Those are all items that will be part of an object or part of a class. So we cross those all off. So what do we have left? We have cars, we have customer, we have service quote. That's what it comes down to. Those are the three objects that we're going to need to create. And the rest of these items, most of them are going to be instance variables of that or objects created from it. So now, we're going to create a customer class. So we're going to create this UML that basically has a name, address, and phone. So there's our customer's name, address, and phone. We're going to have our constructor, which is customer, which we're going to preload with a name, address, and phone number. We've got our 3 setters and our 3 getters. Okay. So we take a look at 14.5. And there I basically have, this is not even looking right. Okay, so here is our customer. We've got our customer name, address, and phone. Here's our constructor. We've got our 3 variables coming in. We've got our 3 setters and 3 getters. Okay. So I come over here to customer, and there I have my constructor. So I bring in N, A, and P, and I go ahead and say this.name is equal to N, this.address is equal to A, this.phone is equal to P. So there's my set name, set address, set phone, get name, get address, get phone. So these 3 getters are using the return parameter. Then we have our car class. So let's take a look at the car class. So I go to my UML. Here's my car. So there's my make, model, and year. So an int. Make should not be an int. That should be a string. So we've got our 3 instance variables, and then we have our constructor, and then our 3 setters and 3 getters. Okay. So again, there is our constructor, there are our 3 setters, and there are our 3 getters. And then we have our service quote. Now, service quote, here is our UML. So service quote, we have two instance variables, parts charged, which is a real, labor charged, which is a real. And then I've got my service quote, which is my constructor. And then I've got my two setters, my two getters, and then I've got get sales tax, and then I've got get total charges. So we have two methods that will do things for us, like we did with gross pay with the employee. So I look at the service quote. There is my constructor. There are my three setters, or two setters, and here's my getter, another getter. Then here's get sales tax. So here I say this dot parts charges times tax rate. So I'm basically calling tax rate. I'm passing tax rate to this guy. Total charges is it's basically bringing in the tax rate again. And I'm basically taking the charges, the parts charged, plus the labor, plus the tax rate, and basically returning it. You know what I could do? I wouldn't have to do that here. I don't have to say this dot parts charge. I could actually say this dot get sales tax and then pass the tax rate to that. That will do the same thing. Oh, well, let me do that. It won't let me do that. In Java it would. No, it still won't let me do that. Okay. I guess we'll leave it the old way. Okay. So, we've got those three created, and then we can go ahead and run this thing. I click run, and basically, so here's what I did. I have my tax rate, which is my constant, and then I create a new car called CusCar, and it's instantiated as a new car as a Chevy Camaro 2017. The customer is Mark Webb. Boom, boom, there's the address. There is the phone number. And then here is I create a quote. Okay, so there's my customer I created. So I instantiate it as a new customer. I use my constructor. I instantiate a new quote. And the service quote is there's my charges for parts and labor. And then here's the bill. So the car bill for Mark Webb. Here's the address, phone. Here's the car, 2017 Chevy Camaro, for the following fees. Here's the parts. Here's the labor. Here's the tax. The total is $327.39. Now, we could create another customer, another car, another quote for that customer. So again, each one of these objects is holding. So I've got this customer car is specific to that customer. Cust is specific to that customer. So I could create another customer object, another car object, another service quote object. So let's talk about inheritance. So inheritance is a way for me to take an existing class and inherit from it. So I could have an insect class, and then I could create a bumblebee class and a grasshopper class. But they're all going to start with, I could inherit from the insect class. All insects have 6 legs, they have a thorax, they have all these different things. Now the difference between a grasshopper and a bumblebee is bumblebee has wings, it's got a stinger. Grasshoppers have those big back legs, okay? And it's got those little chompers in the front. So inheritance is the nickname for that is what's called an is-a relationship, okay? A bumblebee is an insect. A grasshopper is an insect. I could create a dog class, and a poodle is a dog. A car is a vehicle. A flower is a plant. Okay? And so I could create this thing called graded activity. And okay, so continue on about inheritance. So we have this thing called graded activity. So it's a graded activity. We're going to have an instance variable called score. It's a real data type. We have three methods. We have a getter and a setter, and then we have something called get grade. Okay, so let's take a look at that one. This is class listing 14.8. So if we take a look at this guy, oh, come on. Let's try that again. Okay, so here's our UML, here's our graded activity, there's our score, there is our 3. So if I come over here to graded activity, there's my set, there's my get, and here's get grade. Now get grade is kind of a little different. We're looking at if the grade is greater than or equal to 90, it's an A. If it's greater than or equal to 80, it's a B, C, D, so on and so forth. So that's just a class by itself. So now if we come down here, we're going to run program 14.4. So then 14.4 then takes this UML, and we're basically going to create a graded activity object called test. We're going to enter a numeric score, then we're going to need to say test.setScore, so go ahead and load that instance variable up with that data, and then we're going to say, hey, get the grade for that test. Okay, so then it's going to call the get grade activity and return a letter grade. So if we run it, okay, I type in 82, it comes back and says the grade for that test is a B. Okay, so pretty cool. Notice I need a space here. So pretty cool. So now let's talk about inheritance. So I'm going to create this final exam. Now final exam is really an extension of graded activity. It needs everything that graded activity has, but it's got a few extra things it wants to throw in there. So what we're going to do is this. I'm going to open up class listing 14.9, and this is where it gets a little different. So if I look, I'm going to delete this for a sec. So final exam is a graded activity, but it's got a few extra things. It's got a score, and it's got get set score, and get grade, but it's also got number of questions, points each, and number missed. And then we've got a final exam constructor. We have get points, and we have get none missed. Okay, so to make this work, I'm going to come over here and click on this inherits from, and I'm just going to draw over to that guy. Now it looks kind of weird, but basically it says, hey, this guy comes from this guy. Okay, so this arrow comes over and says, hey, everything that this guy has, I have as well. Okay, so it has all of the getters and setters of graded activity, and it has its own here to where it basically then so here's final exam. Here is the constructor. We pass in the questions and the num missed, and we basically create a variable numeric score. This num questions is equal to questions, so we get that. That's basically a setter. This dot num missed, we get it from missed, so we're getting that from what's passed in. And then I say points each is 100 divided by questions. So it's always 100 points. We divide by the number of questions, so we know how much each question's worth. And then I say numeric score is 100 minus missed times this points each. Okay, so if they missed 10, we multiply times what the each question is now worth, and then we go ahead and set this score. Okay. So let's see how this works in a real-life situation. So if we take a look at program 14.5, we can now see what this looks like. So here, I I create a variable called questions and missed, initializes both to 0. I then ask the user for the number of questions in the exam, and then how many does a student miss. And then I create a new instance of final exam called exam, and I pass in the questions and missed. And then I say each question in the exam is worth exam.get points each. And then, where are you working? And then I say each question on the exam each question on the exam counts, and I say the exam score, and then put the grade for that exam, and then I say exam.getGrade. Now realize exam does not have a get grade. So this final exam does not have a get grade, but since it inherits from graded activity, there we have get grade, and there it is basically utilized. So notice this .set score. Where's set scores at? There's no set scores over here. That's also in graded activity. Set scores is over here in graded activity. So again, since it inherits from that, so think of it as final exam has everything graded activity has plus a little bit more. So it can use everything that graded activity has. That's the beauty of inheritance. Okay, so if we take a look to see how that looks, did we actually run it? Program 14.5. So let me look at 14. Yeah, so 14.5. I should have ran it. So 14.5, I run this, and there were 82 questions on the exam. Enter the number of questions they missed. They missed 6. And it says each question exam counts as 1.22 points. Each got, I need to rephrase that. So basically got 92.68, which is the grade for the exam is an A. Okay. So that should have said, oh, the exam score is, okay. Let me fix that real quick. Okay, so that's inheritance. So inheritance says I can, it's kind of like one of the examples I've seen in a textbook years ago is it said, what if you manufactured watches? So wouldn't it be great if you had your basic watch that had just a regular plastic band, had a white face, 12 numbers, and an hour and a minute hand. That's your basic watch. Well, then we want to create a new watch. Well, we start with the basic watch, but now we add a leather band. We now have a glow-in-the-dark face, and we've added a second hand. So it has all the features of the basic watch, but we've now got these new features of this new watch. So that's basically the beauty of inheritance. I don't have to recreate instance variables and methods that basically already exist. Okay. So now let's talk about, so here is that arrow basically saying that exam inherits from graded activity. A final exam is a graded activity. So now let's talk about this thing called polymorphism. So polymorphism is polymorphism allows you to create methods with the same name in different classes. Okay, so basically it inherits, but we're going to modify the method with a different contents. Okay, so here let's look at class listing 1410. So class listing 1410 basically is an animal, and it basically has, is that it? It just basically has it's just got two methods, show species and make sound. Okay, so that's the basics. Show species, make sound. If I look at animal, it's got make sound is grr, and show species is I'm just a regular animal. Okay, there is no main, so we're not going to run anything. Okay. Well, 1411, we'll take a look at 1411 now. And if we look, so here I've got, let's take a look. So I've got animal, make sound, show species, and I've got dog, show species, and make sound. Wow, they got the same exact methods, okay? So if we look at dog, it says put I'm a dog, that shows species, and its make sound is woof woof. So I got woof woof, so it's basically the same exact item, okay? Since they have the same exact methods, the method names, but they do something different, this is called overriding. It overwrites that method with its own. So now let's take a look at class listing 12. So class listing 12 now has a cat, okay? And if I take a look at cat, again, it inherits from the animal, but it now has its own make sound and show species, okay? So let's throw them all together now. To where I have an animal, and dog inherits from animal, and cat inherits from animal. It overrides show species and dog and make sound, overrides show sound and make sound and show species and cat as well. So if we take a look at the main, I create my animal, which is a new animal, and I show the species and I make sound, and then my dog, I create a new dog and I say my species, make sound, cat, make sound, my animal show species, make sound. So if I go ahead and run this, I'm just a regular animal, grr, I'm a dog, woof woof, I'm a cat, meow meow, I'm a dog, woof woof, okay? So as you can see, it just, all of those basically overwrote. When it went to call that particular method, it knew, since I'm in the dog class, I'm a dog object, it knew which method to basically execute, okay? So inheritance, we inherit from one class from another. All of the methods in that other class I have access to. If you do polymorphism, I still have access to those methods, but if I have the same exact method in mind, I can override it so that I can basically do something different. So it won't call the method in the original, the inherited from class, it will basically only call its own first. Okay, so that's basically it for chapter 14. Again, a very complex chapter, a lot of stuff going on here, a lot of class information. Just realize that we create objects from classes. I can create as many objects as I need from that one class. The class is the blueprint. I can create an object. I can take one class and inherit from another class. So everything that's up in that main class I have bound here in my subclass. I can also inherit from that class and change the methods so the methods do something different in my inherited class, which is basically overriding. Okay, if any questions, make sure you give me a call, and we will see you later.